Hello, guys. This is a brief discussion about neuromuscular junction, in which we will discuss about how a motor neuron passes from the presynaptic membrane towards the postsynaptic membrane, and after that, it moves towards the muscle fiber. Now, let's start the function of neuromuscular junction. First of all, this is the axon. This is the axon terminal. These are the vesicles or synaptic vesicles, and these are the neurotransmitters, which are called the acetylcholines, and this is the presynaptic membrane. This is the post synaptic membrane. Here it is. So now start the process. Let's start the process. How the neuromuscular junction works. First of all, the action potential arises at the presynaptic membrane. The action potential arises at the presynaptic membrane. Okay, at the presynaptic membrane and the presynaptic terminal, which causes the voltage gated calcium channels present here to open and passes the calcium through it and passes the calcium ions through it. When these calcium ions are passed through the voltage gated calcium channels, these calcium ions are attached to the vesicles called the synaptic vesicles. When the calcium ions are attached to these vesicles like this attach to the presynaptic membrane. After attaching to the presynaptic membrane, the neurotransmitters called acetylcholine are released from these vesicles from the presynaptic membrane towards the synaptic cleft. Okay, when these neurotransmitters from the presynaptic membrane are moved towards the synaptic cleft, here are present the voltage gated sodium channels. Okay, here are present the voltage gated sodium channels. These are the voltage gated sodium channels. Okay, now when these neurotransmitters reach the synaptic cleft, they automatically attach to their receptors on the voltage gated sodium channels. They attach to the receptors on the voltage gated sodium channels. And when these start to attach themselves to the voltage gated sodium channels on the receptors on the voltage gated sodium channels, the sodium ions start to pass through these channels towards the muscle fiber. And potassium moves inwards to the synaptic cleft, which shows that the positivity increases in the on the sarcolemma or the postsynaptic membrane, and negativity decreases, which means the depolarization increases and repolarization decreases. After the sodium ions are passed into the muscle fiber from the synaptic cleft, the sarcolemma starts to generate action potential. Okay, the action potential starts to generate here. Okay, so this is the process of neuromuscular junction. Okay, now let's give it a quick review. First of all, this is axon terminal, these are the synaptic vesicles, these are the neurotransmitters, these are the synaptic cleft. Okay, now the thing I have to mention here is that these three things, presynaptic, post, and synaptic cleft, are involved in synapses. This is the most important thing to keep in mind, that presynaptic membrane, postsynaptic membrane, and synaptic cleft are involved in the synapses, or involved in the uh, taking of the message from one neuron to the other. And the next thing to keep in mind is that this is the motor neuron. This whole is the motor neuron. Okay, this whole is the motor neuron, from which the from which the and this is the in which this is the axon, this is the axon terminal. The action potential arises to the axon terminal. When the action potential arises to the axon terminal, the calcium channels are opened, from which the calcium passes through, and the calcium binds towards the bind to the what we say, this is synaptic vesicle. From the synaptic vesicle, the neurotransmitter appear and move towards the synaptic cleft from the presynaptic membrane. This is the presynaptic membrane. From the presynaptic membrane towards the synaptic cleft, and from these synaptic cleft, the neurotransmitter attach to the receptors on the voltage gated sodium channels at the post synaptic membrane. Okay, the neurotransmitters attach at the receptors on the voltage gated sodium channels at the post synaptic membrane. Okay, when the neurotransmitter attached to the receptors on the postsynaptic membrane, the sodium channels allow the sodium ions to pass through them and move towards the muscle fiber. When these sodium ions pass towards the muscle fiber, the positivity increases and the action potential is generated in the sarcolemma, at the sarcolemma, and the negativity decreases, which means the sodium ions move outwards towards the muscle fiber and potassium ions move inwards to the synaptic cleft. So this is all about neuromuscular junction. And the last thing but not the least, that is, when the function is completed, there is an enzyme called acetylcholine esterase. The acetylcholine esterase then degrade these acetylcholines. The acetylcholines are degraded and converted into acetic acid and choline. After the acetylcholine is degraded by the acetylcholine esterase, this is converted into acetic acid and choline, after which no function regarding acetylcholine is done here, which means acetylcholine is fully destroyed and there is no use of that neurotransmitter anymore. Okay, Now, here the completion of neuromuscular junction takes place. After the neuromuscular junction is completed, the sodium potassium pump comes here to proceed its function. What's the function of sodium potassium pump? Sodium potassium pump help to maintain the balance of sodium and potassium inwards and outwards. How? In this neuromuscular junction, we have studied that the sodium goes out and potassium goes in, due to which positivity increases towards the sarcolemma. And when the sodium potassium pump takes place, it maintains the balance of sodium and potassium by moving the sodium towards inside and moving the potassium towards outside. That is the condition of every junction, of every neuromuscular junction after the work is done. The maintenance of balance is very important for the sodium and potassium after the action is completed and after the function is done of neuromuscular junction. Okay, now that is it. That's the quick but not the very quickest review of neuromuscular junction. If you have any queries, any problems, you can ask in the comment section. Thanks for watching.